Hello everybody, welcome to my channel. Today we have an amazing problem for you guys called happy number, right? So let's see what it's all about, right? So it says to write an algorithm, right, to determine if a number n is happy. So a happy number is a number defined by the following process. Starting with any positive integer, replace the number by the sum of the squares of its digits. Okay. Repeat the process until the number equals 1, where it will stay or it loops endlessly, which does not include 1. Right? So those numbers for which the process ends in a 1, right? They're considered to be happy. So return true if a number is happy, or false if it's not, right? So very easy to understand prompts. They're very, very good one, right? So how do we go ahead and solve this, right? So we know that we're gonna be given some kind of a number, and we need to find a way that and every time, right, we're gonna replace the number by the sum of its the square of its digit, right? And if the sum of the squares of its digit is equal to a 1, right, then we know that number is a happy number, so we're good. If it's not, then we continue the process. We keep doing that. We keep squaring the digits of the numbers, right, that we get to, right? The different numbers, because we're going to be, changing the number every time, right, by doing this process, because, right? And if we end with a 1, we ever find a 1, we know that that's a happy number. If not, if we end up in a loop, right, in a cycle, I mean, right, that tells us that this number is not a happy number, right? So it's not good at all. So just go through an example. I think it'll solidify the concept even more, right? The understanding of the problem even more. So we're given n equals 19 originally, right? And we need to determine if that number is a happy number. So we keep squaring the digits, right? And we sum them up, right? And then that's why we get 1 squared plus 9 squared equals 82, right? And likewise, but if we get 82, since it's not equal to 1, right, we continue the process again, right? So now we start again, we do 8 squared plus 2 squared equals 68, right? And then we get 6 squared plus 8 squared, right? Because we get this, right? We get 100, right? It's still not equal to 1, right? So now once we finally get 100, right, we sum up all of its digits, right? The square of all of its digits, right? Then we get a 1. Then we return true right away, because that's what we're looking for, right? So example number 2, right? We get n equals 2. This one's it's false, because this one we don't end up at a 1, right? So it's not a happy number. So let's quickly see it real quick, right? So we start off with 2 squared equals 4, right? Okay. And then we go to now 4. We squared the number 4, right? Because that's 1 digit, right? We get 16, right? So now things are starting to heat up a little bit, right? So we get 1 squared plus 6 squared, we get 37, right? And then we keep doing that. 3 squared plus 7 squared, we get 58. 5 squared plus 8 squared, right? We get 89. And then 8 squared plus 9 squared, 145. 1 squared plus 4 squared and all that, we get 42. And then we get this, we get 20, right? And after doing 20, we do 2 squared plus 0 squared, right, equals 2, right? And you can kind of see this, where we will be going right back to where we originally started, guys, right? So we go back to that original number, right? The original state, right? We get but we end up, that means that, there's some kind of a cycle, a loop, right? We're just going to keep going back to this thing that we've already seen before, so that we return false, guys, right? Since we've already seen that state, right? So we could just return true right away, right? There's no point of continuing to calculate, because it's just gonna end up being the same thing over and over and over, right? There's a cycle, there's a loop, right? So it's not good. So how do we go ahead and solve this, guys, right? So we need to know, so to determine if we've already seen a previous state or previous number before, right? We need to have some kind of a data structure to kind of help us in remembering that, right? So that's why the introduction of a set, right, is going to be kind of useful for this problem, right? A set to help us to know states and numbers that we've seen before, right? So that we don't keep doing over and over, right? So we could exit and say, oh, this is a false, it's not good at all, right? So this is like we're gonna do it. So we just gonna have some kind of a while loop, right? And then we do some kind of a calculation, right, every time. So we're gonna get the digits, right, of the number, right, and then we're gonna square them, right? And then we're gonna check the sum of the square of the digits, right? Equals to 1. If it's not, then we continue doing that until we get to some kind of exit termination, right? Where we get a 1, or right, we end up we've determined that we are in some kind of a loop, then we exit, right? So it's easy as that, guys, right? So hopefully you guys kind of understand the thought process. So I think the logic will be a lot more, code will be a lot more intuitive and better, right? So that's I said, okay. So we have the loop, guys, that we said. While the set does not contain n, right? That's what the statement that we're gonna have, right? So we're gonna have a sum variable that's gonna help us in keeping track of the sum of the square of the digits there for a particular number, okay? So we're gonna do a while loop, right, to calculate the thing that we're looking for. So while n is greater than 0, okay, we're gonna get the digits one digit at a time, right? So we're gonna get the last digit every time, right? So we're gonna do n mod 10, right, to get that last digit. And then since we get that digit, we're gonna add it to the sum variable, right? So we're not just gonna do plus digit, right? We're gonna do the digit times itself, right? Okay. That's gonna help us in getting the squared, right? So we add 9 squared, right, to the variable, right? And then what we're gonna do now is truncate, is to remove the 9, right, from the number, right? So we remove the rightmost number, right? And then we're gonna end up with 1, guys, right? And that's how we're gonna keep doing that until, yeah. So we remove the least significant digit, okay? So after we do that, and now it will be equal to sum, right? So before we do that, we're gonna do a check here, guys. If the sum equals a 1, right? If after squaring all the numbers and then we add them up, right, equals a 1, then we know that this is a state that's what I'm looking for, true, right? So what we also need to do, right, as we're visiting the state, we need to add the stuff to the set, right? So we don't end up in a loop, guys, like we said, right? So we're gonna add n to it. And then, right, once let's say we are some kind of a loop, right, we never hit this condition and we hit this condition somehow, right, for us to exit, we return the false, guys, right? It means that, there's some kind of a loop and we don't have a path to 1, right? Okay, so let's press run code, see if we are in good shape, right? It looks good so far, right? So like we said, we start off with the original number, right? We chase 9 in the set, right? Because we haven't processed any number, right? And then we have a sum variable to get the sum of the square of all the digits, right? So we keep getting 1 digit at a time, right? We multiply it together to get the square, right, effect. And then we add it to the sum variable, and then we remove that number, that least significant digit, right? And then we keep doing that until we add up all the numbers, right? And then we check here, if it's equal to 1, we return true. If not, we continue the process, right? The new number now that we're going to calculate is the sum, right? And then we start up over again, right? Just like we were doing in this process here, guys. It's exactly what the code is doing, right? So let's press run code. All right, awesome, guys. We passed all these test cases. If you guys found value, you guys understood the thought process in this video, let me know that in the comment section. If you guys are new here, subscribe, because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.